Hello, everyone, and welcome to this session. I am Dr. Suman De, Head of Government Healthcare Analytics at Infosys Public Services, and today I'm joined by Rajiv Dev, who heads the architecture at Infosys Modernization Practice. Today, we will be presenting you our next generation data and intelligence solution, the Infosys Health Insights Platform that is built in partnership with Couchbase, AWS, and Novi. As a part of our conceptualization, we have spoken to many of our clients and prospects, and predominantly, we have seen that organizations are challenged in operationalizing a standardized approach to manage their data and institutionalize best practices around data and analytics to derive timely insights. And that is what is one of the important aspects that we thought is critical for us to solve through this particular solution. And we took 6 important things, or I would say 6 key tenets that we thought to be very important to improve the efficiency of data to insights journey. Firstly, to enable data freedom and help to unlock and analyze the data which is trapped in multiple legacy apps. Provide more flexibility and efficiency through automation to enable organization easily ingest data from multiple sources, irrespective of type and format. Bring more credibility to their data by establishing a centralized and governed single source of truth, and equally enable quick data extraction for configurable subject areas to share across various downstream and operational decision support apps, and ensure self-services analytics coupled with rich and interactive data visualization, and never to compromise on data privacy, security, and regulatory compliance all through this process. So how we are solving these challenges through our Infosys Health Insights platform? It's just 3 key steps that we are enabling for our customers. We are industrializing the data to insights pipeline. We have automated and codified best practices of data management. We have embedded process and technology in a single platform, all of which has enabled our clients to get reliable insights that they need for their decision making, make insights more timely and appropriate, and make it more shareable across various stakeholders, both internal and external, and make it much more secure through a built-in security. How does our platform differentiate? So we are enabling this journey of data to insights in 3 different phases. And each of these phases brings different advantage. And at an aggregate level, it helps our clients and prospect to optimize on cost and incrementally deliver business value. The first is the process simplification that eases the adoption of the solution and bringing more automation with respect to data integration and data harmonization. Bringing more integrated capabilities that can help organizations to gain more uniform experience of their data and institutionalize self-services and treat it as a one-stop shop that can enable them to run multiple use cases, not only tied up to healthcare, but beyond healthcare. This can be equally applicable for Department of Transportation. It can go to child welfare domain. It can go to finance. It can go to insurance. It can go to healthcare providers and hospitals as well. And finally, we bring in continuous learning and improvement so that organizations can save to invest on more strategic initiatives. And those capabilities help them to democratize the use of data science within organizations and rapidly develop complex AI models with more automation and use of artificial intelligence, and finally drive next best action to enable decision making and foster their time to value. When we were in the conceptual phase of this particular solution and in discussion with our partners, one of the key things that caught our attention was Couchbase ability to provide a 360 view of an entity and further help to analyze that data in multiple dimensions. So in this slide, as you see, with bringing in data from disparate sources and residing it in the Couchbase storage, as a golden record said, we can bring in a population 360 view. And in context to COVID, to understand what that 360 view actually means will help you to better understand that how it is impacting the population with respect to certain hotspot trending or virus spread direction, getting into the understanding of context exposure pattern and identifying the high-risk community. Equally, to gauge the case incidence rate within the population subset and what is the virus reproducibility rate. And finally, what type of alerts and intervention would be required to manage them and bring in more healthcare resources as per the demand of the population. And this is not the end of it. We can further lead this same 360 view to gain a three-dimensional aspect of a specific individual in context. So in this case, say a particular patient, how can I get to know the three-dimensional aspect that can give me more answer to the underlying why? And the next slide actually helped me to visualize that. So when we aggregate the data, we can now blend and put it under a single pane of glass to look at all the three phases of a patient: the present, the past, and the future. And that helps me to understand the patient as a totality, right from a population level, and again, certain next best action that can help to manage the patient better by predicting their future risk and what are the intervention that is needed, which is much more customized, more tailored for that particular individual to be managed properly for their healthcare crisis. So with this, I will pass on the presentation to Rajiv, who can take you through the architectural and design principles of the application, and also give you a quick demonstration of the product to better understand what we have developed together with our partners. Over to you, Rajiv.
Yeah, thanks, Suman. So let me get to the design and the architecture of the product. Now, any good architecture is based on good design principles, and it was no different for us. So one of the most important design principle for us was to be able to ingest any type of data from any source. So polymorphic data ingestion was very key to us. The next important thing that we considered was to make the product cloud native, because we wanted to leverage the innovations that are happening on the cloud. And then the third most important is to have a robust observability layer on top of the data processing pipeline. And the reason behind that is, if anything, if any data processing or if any feed processing, if there is a failure in that pipeline, we should be able to detect it and fix it in no time. And last but not the least, security, data security, whether it is at rest or in motion, was a top thing in our mind while architecting the solution. The next slide shows the overall architecture of the platform. And if you look at it, it starts with the landing zone, right? So for us, the product is implemented on top of AWS, and AWS S3 is our data landing zone. So any source of data, whether it's an external or an internal source of data, it lands on the cloud provider's object store, which is Amazon S3 in this case. And the primary reason for that is as part of the product, we also wanted to standardize the way organizations exchange data or share data with their stakeholders, whether internal or external. Because a lot of organizations are spending a lot of money and effort in managing many sources or many approaches towards data sharing among their stakeholders. And this particular approach will help them standardize and reduce the cost of exchanging data between stakeholders. So once the feed or the data lands on Amazon S3, then we leverage the cloud providers or AWS's serverless eventing framework, or to be more precise, AWS Lambda, to push the feed to a set of data processing steps, which are orchestrated through an open source orchestrator called Apache Workflow. Now, the first step in this processing pipeline is pre-processing. And then what does pre-processing do? So pre-processing takes the feed and converts it into canonical format and then pushes it to our bronze schema in a Parquet format. And that becomes our exploratory data warehouse. So if anyone wants to look at the raw data, that is the schema that people will have to go to. The next step after pre-processing is the validation framework. Now, one of the key things that we, or one of the key objective of building a product like this was to ensure that no garbage can move to the data lake. And that is what the validation framework is ensuring here. So we have a extensible validation framework where you can plug in any type of validation rules that you would like to apply on the columns or on a particular row or on the feed, the overall feed as well. And the validation rules can be either written in SQL or Python scripts. And it's more like a configuration over code. One of the examples of a validation rule is if you want to check that a particular business column is not null, right? So you'll plug in that validation rule in the framework, and that framework will validate. And if the validation is successful, then only it will let it go through the next step. Otherwise, it will fail it there itself. Now, after validation, the next step is called normalization, and then this is the step where the normalization process is extracting the subject areas for the given entity from the feed, which is defined in a feed configuration file, right? And that is one more very important aspect of our product. Since we focused on configuration of our code, we focused on externalizing all processing steps in a configuration file so that any new feed, any new validation, anything that comes as new, we should be able to set it up through a configuration rather than change the code. So that makes the product more extensible for us, right? So normalization not only extracts the feed or not only extracts the subject areas of the particular entity from the feed, it is also capable of leveraging a business rule engine. It's rules that we have used through which it can apply business rules on a particular column or a particular row again, right? For example, if one of the column is diagnosis code and we wanted to derive some business logic based on the diagnosis code, we have externalized that rule into the rules engine. And tomorrow, if there are additional rules engine, it's just writing that rule in that particular rules engine and configuring it to apply it in the normalization phase. So after the normalization phase, what it has done now is it has extracted the various subject areas from the entity as separate JSON fragment and is pushed into a silver schema in the Couchbase store. The consolidation phase consolidates all those JSON fragments or all those subject area. And to make it more clear, an example would be for a patient entity, a subject area would be patient demography. Another subject area would be, let's say, the patient disease history. Another subject area would be patient pharmacy visits. So all those subject areas, the consolidation phase consolidates this together into a single document for a patient and pushes it to the gold record in Couchbase, which becomes our clean data lake. And I'm stressing on the word clean data lake because that was what our objective was, not to create a data swamp, but to create a data lake which is augmented, which is clean, and which now can be pushed to the enterprise data warehouse. So in that part as well, we have an automated approach of creating the data warehouse model, be it Vault 2.0, Kimball, or Snowflake. We can automate the creation of the framework and then push the data to that data model. Now, the data lake, the gold record, the data lake also feeds the data marketplace module in our machine learning platform. And I'll talk more about the machine learning platform when I actually demonstrate the platform. But the machine learning platform is able to access the data lake, and the data lake data, all the entities that are in the data are exposed to the ML platform so that it can do exploratory analysis on the data and then create the model store. The next slide talks about like why did we choose Couchbase when we had a lot of other options or other technology options to choose from. Primarily, Couchbase's memory-first architecture and its schema-free document store. These are the two most important things which led us to decide to make Couchbase as our data lake store for the product. But apart from these two, the multidimensional scaling within Couchbase, which allows you to scale each of the components of the data processing, like query processing or index processing or analytics processing. The multidimensional scaling feature can independently scale each of this processing. Right? So that was one of the other beautiful feature of Couchbase that led us to choose Couchbase. And in future, we are also planning to leverage Couchbase analytics for the exploratory data analysis of our machine learning platform. There are a lot of built-in EDA features that are coming up in Couchbase, and we will adopt all those features to make our machine learning platform much more efficient, much more mature, and there will be a lot of other approaches towards exploratory data analysis. So this slide, I'll not spend much time on this slide. This slide talks about our machine learning platform. I will be showing a live demo of the machine learning platform that will make it more clear how the machine learning platform integrates how it is integrated with our overall Infosys Health Insights Platform, how it takes the data from the data lake, does the data discovery, acquires the data, prepares it, does feature engineering. So we have plugged in a automated feature engineering part also in a machine learning platform. And there is a concept of if a data scientist wants to bring in his or her own feature engineering or an algorithm, it is very easy to plug into this machine learning platform. So it also helps you to develop the model using AutoML techniques and then deploy it to a model store. And model store is a very unique feature that we have implemented. The model store would be like any model that has been developed through this platform will be available as an object in the model store, and any consumer, be it an application developer or an external stakeholder, can log into the model store, can play with the model store, can find out the effectiveness of the prediction of the model, and then consume it in their downstream applications. That's a very unique feature, and I'm going to focus on that when I demonstrate the machine learning platform. So that's all I wanted to talk about on the PPT side of the presentation. Now it's time for a live demonstration of the product, because the proof is always in the pudding. So let's take a look at the demo. So this is the landing page of Infosys Health Insights Platform. So if you look at this page, you'll see there are 4 core modules in the platform. The first module is user management, and this is the module that helps to set up role-based access in the platform. The platform will be used by many different users. The user can be an application developer, he can be a data scientist, he can be a data steward, he can be a data owner, right? And each of these users will be able to do certain type of functions in the platform. So the user management module helps to set up roles, users, and the privileges that are assigned to a role, right? So that each role can access whatever they're supposed to access in the platform. The next one is the data feed monitor, and this is the observability layer that I was mentioning previously in the session. So any data or any feed that gets processed through the platform are monitored using this real-time feed monitoring observability layer. So I just processed this data set. So if I bring up this data set, I can see that it has gone through the various data processing steps, starting with ingestion. And ingestion further has sub-steps. So there is a data reader component. So what this data reader is doing, it is looking at the configuration file of the feed. So in our platform, every feed has a configuration, JSON-based configuration. And the configuration defines the feed. Not only defines the feed, it defines the processing of the feed as well. So for example, who is sending the feed? What is the frequency of the feed? What is the format of the feed? Is it a CSV? Is it an Excel? Is it an HL7 file? Is it a multi-format file? Right? Those are all defined in that JSON configuration. In addition to that, the configuration also defines what are the attributes that I need to extract from that particular feed. So the data reader looks at the JSON configuration and says, okay, it is using S3 profile. So it automatically instantiates a S3 reader object, reads the file, pushes it to the data processing component of the platform, processes the data, and finally writes it to a Parquet format. Here again, the Parquet reader, the Parquet writer is automatically instantiated by the data writer factory, right? And right now we also have CSV writer, we have an HL7 writer, we have a JSON writer, right? So based on what has been defined in the configuration, the framework or the factory pattern here will instantiate that object and that writer object and write the file to S3. The next step it is showing is that the feed has gone through validation, and data validation is a very important part of the framework. This is what prevents any garbage to flow ahead of the data processing pipeline. If a validation fails, the data feed processing stops just there for that feed. It does not allow it to go further in the data pipeline. So this is again a very extensible framework. You can have your own data validation rules either through an SQL or a Python script and can plug into this framework. And the last one is a normalization part. It also has certain sub-steps. One of the most important one is the rule execution part, and I spoke about it previously in the session as well. So this is where it augments the data by applying more business rules on top of the data. For example, if a column has come in as diagnosis code, right, and I want to apply some rules on the diagnosis code to add some more derived fields to augment the data, this is the place where I need to plug in that particular rule. The rule per se is already defined in the configuration, and the rule object, the rule processing logic is in the rules workbench, which is running as a separate server on the cloud. And finally, the normalized data gets written to the Silver schema. Right? So this is the real-time feed monitoring dashboard. You can monitor all the feeds, all the data that is coming for the day, and monitor it on a real-time basis. There is a historical feed monitor as well, which shows you, by default, it shows you today's data processing or feed processing status. How many feeds came in, how many feeds got processed, how many feeds are queued for processing, or how many feeds have failed. Everything you can look at it through the historical feed monitoring. As I mentioned, the default is today's date, but you can always see what happened yesterday or day before yesterday or a week back or a month back or even a year back. Right? The next module is the visual analytics module, and it is one of the most interesting and an important module of the platform. So what it helps us to do is, so whatever data or feed we have processed so far, so in this particular demonstration, we are using patient data. So the data processing pipeline has extracted a lot of subject areas related to the patient, like the patient demography, patient disease history, patient pharmacy visits, patient's hospitalization records, and all. So with all this data now available in my golden schema in the data lake, NOI, which is the visualization product that we are using in this platform to retrieve that data and create this visualization. So NOI is enabling this visualization for us. So for example, this particular visualization, through this I can find out which patient has the highest clinical risk and also contributing a lot to cost care, right? So this is the patient here. When I click on it, it will bring up that patient. I know his now his name is Guang Lup, and he is located here. This is his address. It also retrieves his record. When I click on his record, I can further drill down to his medical history. Right? It shows all the diagnostics, his medical diagnostics, his past medical cost history, where his medical spend is happening more. So basically what this visualization is doing is, it is helping me to look at Guang's past, and then I can look at his present also, which is how he is interacting with the social media. What are the thoughts that are coming to his mind when he is publishing something in the social media, right? So looking at his past and his present, I can now look at what should I suggest to him as a medical officer or a doctor. What is the next best action that I can advise or suggest to him, right? So this is a very powerful visualization. Apart from this, there are other visualizations that are possible. For example, the population risk profile, right? What is the non-clinical risk, clinical risk, the socio-economic risk score of a population, the readmission probability. In fact, we have the COVID visualization also as part of this, which talks about the infection projections. It actually shows you the hotspots that are built up in a certain geographical location and all. Now, in this visualization, there is one more very interesting view that I want to show you, which is the claims graph view. And this is where we are using a graph database called Neo4j to give us this view. So here, if I pick up Guang Lu, I can look at his claims, all his claims. So basically, it is showing me all the claims of Guangloop, who the provider is, and then if I hover on a particular claim, it gives me further details of that claim. Right? So using NOE and Neo4j, we are able to generate some of the powerful insights through the visual analytics module of the platform. Right? The last module, which is also the most new module in the platform, is the machine learning and the AI module. And this is the landing page of the machine learning platform. So this page is the data marketplace of the platform. And what do I mean by data marketplace is, so right now you are seeing the patient related data, right? The patient is the entity and you are seeing the patient subject areas, socioeconomic health scores, patient demographies, right? But this data marketplace is capable of publishing other type of data also, whether it's an external data source or an internal data source. So whenever a data scientist logs on to the platform, in the data marketplace, he can see all the sources of data that he may need to create his prediction model. So for now, he is interested to create a prediction model for the patient. He wants to predict the clinical risk of a patient. Now for that, he has pulled up the patient entity, and the features that he needs are age, which will come from the patient demographic subject area. He selects that attribute. Next, he selects some of the attributes from the patient hospitalization subject area. From here, he needs his ER visits for the last 12 months. He needs his IP visits for the last 12 months. The condition of the patients and clinical risk, right? So the clinical risk is something that he wants to predict. So this is what will be used to label the data set. Hence, he needs the historical data for this particular feature also. Then he will push the data for AI modeling. So what the platform is asking now from the data scientist is that, okay, I now understand that these are the features that you need. I'll pull those features from the data lake, but give me the data set name that you want to store it to. So I'll say prediction for clinical risk, right? So as soon as I say okay, what is happening in the background is that the platform is retrieving all these attributes from our golden schema, which is in Couchbase store, which is also the data lake. It is going to the patient entity. It is picking up each of those subject areas that I have selected. Within the subject area, it has picked up the features that I have selected. With these features, it has created a nice little data set for me and pushed it into S3. Now let's go and take a look at that data set, right? So which is the next step in the machine learning process. I'll go here. I will look at my data set. I think I named it prediction for clinical risk. This is my data set. The next thing that I'll do is I'll hit analyze. So when I started analyzing this CSV, what is happening in the background is it is picking the data set from S3. Then it is doing an automated exploratory data analysis, as well as some basic feature engineering on the data. So if I go to the view exploration, you will see that it has picked up that I have this many columns in the data set. It has also automatically suggested whether this particular column will be a feature column or not a feature column. As a data scientist, I can still go and change it if I think, no, it needs to be not a feature. But the system itself automates or recommends you or suggests you that this particular column will be good for as a feature, right? And it does it based on some rules that we have, like whether it's a categorical value, if it's a categorical value, how many unique values are there. Based on that, the system itself takes some decision. It also analyzes the data to check whether that particular column has good data or not. Is the data healthy? Right? And for that, it looks at the spread of the data, the skewness of the data, what is the kurtosis of the data, if there are huge percentage of missing data in the column, right? Based on that, it determines the health of the data. It also calculates a lot of statistical or numerical measures of the data. And the most interesting part here is the data profiling report. If I click on the data profiling report, and if you pull it up, you will see that it gives me an overall view of the data. How many variables, how many numeric variables do I have? How many of them are categorical values, right? And then for each of the variables, then it gives me more detailed analysis of that feature or variable. How many distinct count, how many unique values are there? Are there any missing values? It also shows me the histogram of that particular feature. It shows me some of the things like the interquartile range of the column, the fifth percentile, the minimum value, the maximum value, the mean, the skewness. For example, this age here has a negative skewness, right? The variance, right? These are all very important information for a data scientist when he wants to do a exploratory data analysis. The other thing that it has given me is a correlation chart also between the various features. It has given me both Pearson and Spearman correlation that helps me to identify which features are more correlated to each other, right? So this is a very powerful insight to the data scientist. Now, once the data scientist looks at the data, does this exploratory data analysis, and he is now okay with the data and wants to move on to run a algorithm on the data set to predict the target that he wants the platform to predict. So first thing he will do is he will pick up the prediction column. So here the data scientist wants to predict the clinical risk of the patient. So as soon as the clinical risk is selected, it becomes a target. And then when I go to the model type, you'll see that it has already selected the classification algorithm for me. So the platform knows by the column name that it's a classification problem, right? So now when I start the analysis, what is happening in the background is the classification, so the algorithms related to classification, and it is not a single algorithm that the AutoML is applying on the data set now. When it shows the algorithms, you will see that simultaneously it has started applying or training the data set with 3 models, and it will pick up one of the model as a leader model. And it trains the data set with the best model in the best amount of time, right? So if you see, it has picked up deep learning, DRF, GBM, right? And I can also look at the progress of this modeling that is happening, where each step of the processing is, right? And now you'll see that GBM is done 100%. So once the distributed random forest and deep learning both are done, it will pick up the leader model. And that leader model is a model that you'll be using to predict the clinical risk, right? So if you see the leader model has been picked up. Now, if I look at the view metrics, it gives me the various metrics or the interpretations of the model. It gives me the RMSE score. It also tells me which variables played a major role in the prediction, right? It gives me the log loss, right? And now the leader model, like how it selected the leader model also based on the AUC score. So whichever model has the highest AUC or the area under curve score, it picked it up as a leader model. So now that I have the model created, what this platform has done with the model is it pushed that model into the model store. And this is one more very interesting or a very important concept in the platform. So this model store exposes all the models that are developed through this platform. So think of this model store as like an Amazon store, right? People go to the Amazon store to buy different things or clothes, right? So the model store is where people, your consumers, your application developers, your external stakeholders, they will come to this model store to look at all the models that are available, and they can pick up the model that they want to deploy for their particular business requirement. But before they can deploy it for their particular business problem, they can play with the model. For example, if I click on the clinical risk, which I have just created, I can try it out. I can give it some of the feature values. For example, I say age 45, ER visit 12, IP visits 10 times in the last 12 months. And when I execute, it will give me the prediction. So I can pick up my model from the model store, play around with it with different data. I showed the API way. I can also upload a data set by choosing the data set from here, and then get the predictions for a number of features together, right? And once I'm satisfied, I can take this URL and use this URL to predict based on the different feature inputs, right? So that is all that I wanted to demonstrate today about Health Insights platform. So to conclude, I just wanted to highlight that it's Health Insights platform it's an end-to-end data processing, data ingestion processing, and data analytics platform. The 4 core modules again are the user management module, the data feed monitor, visual analytics, and the machine learning and the AI module.